Phoenix Week? Well, Phoenix Weeks are weird because if there's a canteen, and if you lose class, then a Phoenix Week is only 4 days. But if there's a special trip like Stone Lab or something like that, then yeah, it's even less days. So your homework, sorry, I need to put that up, and it should have been my beginning slide for the thing, is 413. And as always, I'm going to try to give you only 5 or 6 problems. And these should be easy once you get the hang of it. So it's 28 to 33.
Are you guys still doing like the opposite thingy, like 27? No, I think there's probably a better way to explain that. What is that thing where you like take two? No.
Now I'm going to try to get you guys your test back at the end of class today, but that's if we can get to it. Both, like all of them. They're both on quarter 2, and they're not in math yet, but they're in my grade book because I keep my own Google grade book.
Wait, did you?
So, if you were not finished or whatever, like, my grades are kind of fluid right now. It's not math grades right now. Like, there are people that just have fix for mastery. You don't really have a progressing, but if you don't fix it, then I'll have to give you progressing. Like, so I try, for those of you who are still not like familiar with my teaching style, I want to give you guys your tests back before I put them in math, because I respect you as a human being, and it's your work, and your parents don't need to micromanage you. If you can take care of it in like a day, sometimes I give you like 2 days, your original grade will never go into math unless it's a good grade. And if you need to like do anything, if you take care of it quickly, then the revised grade is what goes in math. So like say you get a progressing, but you take care of it that first day you have it back, like you get it to me in extensions today, your grade's never going to go into math as a progressing. I'll just put it in as mastery. And it just looks like you mastered it the first time. Which doesn't really matter, but some people's parents like really get on them about things. So that's why I've kind of built in that like grace period. Now we may end up wanting to use algebra tiles, so I'm going to get them out, but make it your choice whether you come get a bag or not. Some of us can visualize this without the manipulatives. Some of us can't. And I'm in the camp of like, it's much easier when I actually think about the physical structure of making the object like I have on the chalkboard right there, which I need to take that down because now it's kind of old. But when I think about making an x squared with 6 x's and with 9's, can I make it into a rectangle? And if I can, factoring it's easy. If I can't, then obviously I'm going to have some partial numbers or some rational numbers. So today what we're doing is more factoring to try to get comfortable with this. I would probably advise that your group at least has 1 bag of tiles at your table so you can like maybe share the 1 bag. You don't each need your own bag. You can probably just share 1 bag and like try to make the structures together. So if you want, put a book or something in the middle of your table group, or I guess you guys just have a flat table, so you're lucky. I wish I just had 6 of those in my room. Actually, 6 square tables would be better, probably.
Wait, did you grade the not like everything that it did?
Yeah, I gave feedback on everything. Yours says needs to finish. Like that's your grade right
But
now.
like, did you grade it?
Yeah, I gave you feedback.
No, on the stuff that it did.
Yeah, I marked right and wrong on the stuff that you did. The stuff you didn't do, there's nothing to provide feedback on.
But does that mean I got all of them all right?
No. And it also doesn't mean that you made any mistakes. I'm not telling you anything about right versus. I'm just telling you I provided feedback to everyone. So if we think about x squared plus 6x plus 9, could we make an actual rectangle out of it? Now, notice what it says. Use a diamond problem in an area model. So because one easy way to set this up, and as soon as I walk over there, it's going to jump to my input. Is that up there right now? Remember, when we talk about the area model, I don't like the diamonds as much as I like the area models. My x squared and my constant both get their own space. Right? So between these two, I'm going to make 6x. Well, I know that I have to have something x there, and well, because there's no coefficients aside from 1, right? There is a 1 there, so there's not no coefficient. And then, oh, well, I think this one got easy.
Yeah.
How do I make 9 and then also likewise make 6x? 3 and 3, right? So this becomes 3x, this becomes 3x. Now if I needed to use my diamond to do this, do we remember how to do that?
Oh, you equals. Yeah, you just like flip it.
You put x squared and 9 squared on the top.
Wait, what?
9x squared, right?
9x squared?
No, wait, what?
No, x squared's up here, 9 is here.
Bottom.
9 is here?
Yeah.
Why?
I thought this was 6x.
Oh. Yeah.
Was it?
And I'm gonna leave this because apparently we need some refresher. If you need a refresher on how to use the diamond, flip back in your book. Your group should have at least one textbook there. I'm gonna give you guys a few minutes. Try to work through A through D. So obviously A is kind of easy. We know that it's x plus 3 squared. But the other ones are not as easy. Right? So you can either use your algebra tiles, and I'll review this in a moment, but I want you guys to flip back on your own and try to review that. How we use those diamond problems.
Or the rock. We'll probably be in the math one. This is the dude.
Oh!
Chapters 5, 10, whatever it is, I shall find out. First find it. Hey guys.
224. If you're looking for help.
220.
Yeah, I know. Sometimes it's ahead of where we are.
I thought you were talking about unit too.
No, 224. Go to page 224 if you're looking for help with trying to use that diamond method.
That's what I said. You multiply these two, so you get 9x squared.
I was just looking for a justification of why, because I had 3 different things said to me. I wasn't going to tell anyone they were wrong.
Oh! Wait. Yeah, and then you put the thing where that would be set.
Trust me, as these problems get hard, the diamond method helps. So, Steven, let's vindicate you. Right? You know what it means, like, be vindicated?
Nope.
You, like, you're like, aha, I told you! Like,
Yeah.
so, you're saying we multiply these, and that goes where in the diamond? The top. And you don't really need to make a diamond, you can honestly just make the X. What do I put in what else do I do?
You can put the 6x in the bottom.
6x here?
Yeah.
Because these, your left and right, your pieces or factors or whatever you want to call it, they're going to add, right, this region and this region to make your middle term, your bx. So this becomes 3x and 3x because when added, they make 6x, but when multiplied, they gotta make the 9, but they're not actually gonna multiply 3x and 3x. They really just multiply the 3 and the 3. We don't care about that though. For the method that we're using here, we get 9x squared, and then can figure out that the 3x and 3x work. I can try 2x and 4x, it works for the 6x, doesn't work for the 9. I try 1 and 6, works, nope, oh crap, dang. Or 1 and 5, or like, I can try other things. This is the only thing that works with the integers. So then your coefficient here tells you what you're working with.
Let's try the next one.
Yeah, try your next one as it gets harder. So I'm going to capture this up onto the TV to give that reminder.
Well, that's not that hard.
Likewise, if you know these terms, notice that that cross multiplication comes out to be the same. That 3x times that 3x.
Squared 4. That's the part I get. The bottom one will just be.
Here's how that should be built.
Can you take this two? You multiply together. It's 6x squared.
The bottom is your bx. So whatever your middle term is, that's what goes in the bottom there.
Squared.
Yeah.
For the rectangle, the diagonal, like which numbers in the diagonal after for the rectangle?
I mean, yes, if we're going based off area model, like, but you could build it differently. But your 2x are going to be at the top left, and your 3 will be at the bottom right.
Yeah.
But they're still diagonal, so you're still going to get the same cross product.
So once you get have they all gotten the cross product? Once you get the cross product, how do you factor that to like?
Ask yourself, what two numbers will add to 5 and
No,
multiply to 6?
I got those numbers.
Okay.
And then you plug them into those.
So, what are those numbers?
2 and 3.
So, x, right? But that means, okay, so one of these is 2x and one of these is 3x, and I need to figure out which, or it might not even matter. But for this to be true, for that and that to be true, this would be 2x, right? And this would be x.
Yeah.
And
The top one would be
That was a good one.
1.
and then the other one would be 3. Yeah, then what do you do?
Those are your factors.
You're literally done.
Hey, so come back with us.
I just don't do what you're asking.
Come back
for.
with us. Satya's making another thing harder than it needs to be.
No, what? What are you asking for?
So, what we are asking for. Hey, there's a lot of laughter for us to, like, we're trying to do things right now. We're trying, why are you so small? We're trying to factor this trinomial, 2x squared plus 5x plus 3, into its dimensions. Binomials. Yeah, multiplication of binomials.
Oh, so we're going backwards.
We're breaking up the trinomial. We're factoring. Factoring's always going backwards. So we now figured out this x plus 1 and 2x plus 3 should work to get that trinomial.
I get what you're asking for now.
So finish out C and D as your groups. I was going to say alone, but I don't want you working alone. Finish them out as your group. Now, what we're also seeing is if we try to physically do this, we could. 2x is wide, 3 constants wide, or 3 like of the x tiles up, but the width would only be 3. And then only 1x tall, and then 1 of the x tiles running long, and then we'd have the 3 constants left up here.
One more time. How do you get the bottom?
The bottom, it's the middle term. It's your bx.
Okay.
This is always your bx. Reference your book. Now, what I don't like about the math notes box in here is they give you a trinomial at the top that is not the trinomial they work with. So if you go look at your math notes box, I don't know if I can get to it anywhere. Yeah, I can get to it here.
If it's negative 7x squared and 5x.
Yeah, well, what are the other two?
the hard part.
What adds to 2 adds to 5?
Adds to 5.
So, and you could honestly do this in your book.
7x squared.
These are separate.
So there has to
The
be
top part of the box is separate from the bottom part of the box.
Wait, what was
Satya, let's make sure you got this before, like, because if they get it and they're talking up here and you're, it's
No, I get it.
this.
10x would be in the 10x would be in the bottom, then you multiply 8 and 3x squared to get the top.
Yes. So 24x squared goes on top, 10x goes at bottom. Think what factors of 24 add to make 10. Then they fill in the 6 and 4. These go in there, and then we have to figure out how the dimensions break out based off that.
What? Oh, it is.
What, the last one?
No, C.
C?
I can't see. No, that didn't even make sense. Oh, there's 5x in here, right?
Yes.
stupid.
Maybe. Okay. What if we
What
do
makes
14
5x?
to -1?
I wanted to say 2 and 3, but no.
That doesn't multiply that equals 6.
I know.
And you forgot the x.
Okay, so what multiplies?
So
Negative
one of
14.
them has to be negative.
I mean, something that equals 7.
Negative
3.5 doesn't work.
3.5 and 2, that wouldn't work. You
I
could,
just said that.
yeah, that's why I said that wouldn't work. Negative 14 and 0.5.
Also doesn't work.
Keep going bigger, guys.
14 and negative 0.5.
Just figure out what can multiply 7.
It is.
3.5.
Oh, I'm so dumb. It's obvious.
-7 and 1 doesn't work.
No, minus 6 and 1. No, 6 and minus 1.
It's
That's
not
not
multiply
multiply
7.
No. What?
Okay, let's try the diamond thing.
I have been trying the diamond thing.
I'm not talking to you. It's confusing. Are you in my group?
So, if I'm thinking about my factors that are going to make -7, right? The thing that's going to live there and the thing that's going to live there. What do we know if we know the product is negative?
It's gotta be negative, positive.
One's negative and one's positive. Wonderful. Off to a great start. So one of these will be positive and one of them will be negative, which means they argue. Who wins?
Negative.
Oh yeah.
Positive.
Oh wait.
Positive wins, right? To make a
Oh,
total area of, but that doesn't just mean that there are 5x tiles. I could have a lot more than 5x tiles, but then I have some positives and some negatives, right? That cancel each other out.
Yeah.
So, what factors of -7, one positive, one negative, we'll figure out which one's positive and negative based off. We just need the bigger one to be positive. Add to make 5, but one's positive and one is negative. Add to make the 5, positive 5, but multiply to make -7.
That's the part that we can't figure out.
Wait, which one? What's the word? I don't know if it's prime or not prime. Prime when it can be multiplied by whole number, whole integers.
Does it matter right now?
Yes, because it can't be multiplied.
Are you talking about composite?
You could just use
You couldn't use 1 and 7. No! No universe works. You couldn't use 14 and 0.5, 3.5 and 2 when it works. That would be 5.8.
1 7.
I heard somebody say something interesting.
Alright, and just keep it all.
Probably me, because I'm saying dumb stuff right now.
No, interesting isn't good.
Oh, well. Probably.
Probably wasn't something me. Probably wasn't me.
It was probably
Just saying
I didn't say
dumb
anything.
stuff.
I didn't say anything.
I know.
I was thinking of many things, but I didn't say anything. Okay, 7 and 1. Guys, look on the board.
1.75 times 4.
What did you do? I think this might help. Someone just say
Oh, my illusion there.
1.14 and -6.14.
what?
Who the hell
That's
thinks
the
of
answer.
this?
I no longer
Satya,
work
you're at
here.
school.
Who the heck thinks of
There
this?
you go.
You don't say that here.
So what that shows us is this can break down. If there are no nice factors that work with the -7, and this could be different depending on the coefficient out here, and the b value, we can just say this is not factorable in like whole numbers, integers, what we're working with what we're trying to do right now, this is not factorable.
Okay.
So move on to D. No, because the struggle is where you learn.
This is hunger.
It's where we learn.
The struggle is where you learn.
Learn to give up.
Yeah.
We are learning to give up. Right?
Just give up already. Come on, you're not gonna work.
Give up well.
You're gonna go down flames.
I know you guys think that's funny to say, but none of you actually feel that way because when I give you a challenge, you can't stop.
Well,
No.
no.
Exactly. And that's the problem.
Because then you just have to live with the fact that you've never found out the problem.
Exactly.
So you end up just googling it.
Minus
I don't
4.
Three
-42
times-
m squared.
What's 3 times?
Now I will tell you this is factorable. So before you get mad at me or anything else.
Oh,
It's too
what the
late.
heck?
What? Which one is this? Oh yeah, I already did that one.
Okay, Thomas.
It's not nearly as hard.
Oh, that's easy.
52.
Yeah.
That's easy.
It's not.
That's easy.
Oh.
You not know it?
I've got 40. Wait, it's 52? I've got 42.
Oh yeah, sorry, my brain carried too many ones.
42.
Wow, I did that wrong.
So what adds to m and multiple?
Factors of 42 that then actually just have a difference of 1. Factors of 4. So like
6 and 7.
now, which
Wow.
one gets the positive? Which one gets the negative?
7 gets positive because it's a positive number.
Wow.
I feel like it's cheating.
So there's a reason why they gave you C before D, and this is real. Like I love when I'm realizing, like, oh my gosh, whoever thought that up was like that was really great. They gave you C because if they hadn't given you C and just gave you D, you might tell yourself, well, this doesn't work because I have a positive there and a negative there, and like what the heck is going on? But thinking through C and that struggle of like none of these work, what you're really looking for in D is factors that are 1 away from each other. Right? Because they're going to fight. They're going to counteract. This, what I really hope you see from here, this coefficient, if that is negative. Hey guys, give me your attention for just a minute. What this is trying to get you to see, because this is a good strategy, put in your back pocket. If that's negative, which really means, if that's negative, we are actually using this as the difference between factors. If I ignore signs for a minute, and I'm just thinking through my factor lists, we're looking for two factors, a difference of one. Then, based off positive, negative, you assign the positive or the negative wherever they go. So when this is negative, this is honestly kind of acting as the difference if you drop signs from it. It is still the sum, but in my brain that's harder to think through like that. So now special cases, right? So we're used to quadratics in the form of ax squared plus bx plus c, but what about when they're not in that form? So, nope, we're not doing the quadratic formula yet.
Wouldn't that be just 0 on the bottom? Would that be 0 on the bottom?
Try them. Try these out. I'm not going to answer any questions until you engage with this for at least 4 minutes. I'm giving you a minute per. I don't even think you'll be done in that time. You might.
Everything for us is
C, I would argue C is in the wrong order.
Yeah, but order, but
And D also, but you can rearrange
wow, would you look at that?
as long as you keep signs with what they belong to.
It's called commutative property. Whatever. Commutative property.
It's commutative.
Whatever.
There's an N.
Engage with this.
Not commutative.
Stop right there.
Yeah.
Do your work. Quit waiting for me. It's like a baby bird waiting for its mom to chew its food. Do your own thing. You are not a baby bird. You can fly on your own.
What are you stuck on A? No, I'm talking
Wait.
for A, like what would add up? What would add up to 0 and multiply to 36? No, I already got it. Yeah, negative 36. So it would be a negative 6 and 6.
X.
Okay, chill. Thank you. Got it.
Oh, no.
You got 2 minutes left. I think from the time that I had said I
All
would
of
give
them
you.
or just A?
All of them.
Crap.
Crap. Heck.
I got the first one, so that's all.
16X be
Okay. This makes sense. Yes.
I don't see.
Sophia, that's
I do see.
Do you though?
Yes, I do.
You have to have eyes to see. If you don't, you cannot.
Oh,
Other changes. Dum dum dum. I'm smart.
What two numbers?
Oh,
That's
that's- yeah.
One of them has to be 0.
yeah. 16 to 0.
Minus 16x is 0.
Yeah.
Yeah.
How do you get minus? Oh, it is a minus. Never mind.
Bottom.
I didn't see it.
Yes.
Finally.
Oh, that was C is easy.
Once you figure out it's hard.
Anyways.
It's probably hopefully it's factorable.
Anyway, did you get through all? Oh, it's
I
easy.
got the first one.
Yeah.
Second one.
And take negative 10. Negative.
Oh, dude, so you're not figuring it out.
No, it's negative 6 and negative 4.
Yeah. Okay.
Bottom one would just be same.
Do you want more time?
I'll just like 30 more seconds.
So the
I'm not trying to be, because I know I would not guess anything.
minus 100 and
40 minus
crap.
0. Bottom, that would be negative 100 again.
No, because the top's not 0.
Top is 0. What do you mean? 40 times nothing equals 0.
No, wait.
40 times. Wait, Mr.
40 times 0 equals
No.
0, so.
For some reason I thought
Oh, wait, are all of us done? Ugh.
What is this?
Don't say it.
I'm not saying anything, I'm just confused.
Don't say boyo. So what is this, sorcery or McDab?
this is sorcery, my boy, McDab.
What is
Sounds
Christopher
like
here?
Christopher.
I know. Sometimes those
This
get
is
too.
sorcery, boy, McDab.
No.
Okay, so.
And
His
let's
first
check.
text was like,
In
what is up,
A,
my dad? And like, don't
Oh,
say
no,
it.
we have no B term.
Nope, we can find it.
Mid, what are you thinking?
For 9x squared, I did 2x and 4.5.
What? There's what? You couldn't do negative and positive.
But how's that work out to cancel out your middle terms? Your BX, because there's no BX.
They're supposed to find B.
No, so BX right now is 0. Jacob?
Okay, so.
Right here.
6x, the other would be negative 6x.
Yeah.
I need my factors to add to 0. So the factors you just gave me might work, but they don't add to 0. If I do 6x and negative 6x, they add to 0x, making one of these.
6x and one of the other shit's negative 6.
So if we think physically with the tiles, guys, some of those would be red, right? Some of my x's would be red. But so then what does that make my dimensions here? I'm guessing maybe 3x, because they're going to cancel out, so I need to kind of be the same, yeah?
-2 and regular 2.
-2 and regular 2. This is a special type of binomial multiplication, and I would like for you to write this down.
Oh, that's. Oh, it's
Anytime you see that there's a bx of 0, because this actually was 9x squared minus 4, no bx, this is called a difference of squares.
Can you just write 3x plus 2 squared?
No, that won't get you the right
Oh,
answer.
mine.
3x plus 2
That's
squared
mine.
would end up giving you 24x in the middle.
I know, it's a minus. That's all
Or,
minus.
sorry, 12x in the middle. That's why it is a difference of squares. Because they are different.
Will that be on our test?
Okay.
Now, think about what has been done to the parabola. Parent function is x squared, right? What's the 9 do? How's the 9 change the parabola? We played with this last week, or 2 weeks ago on
Make it
decimals.
wider? No.
Yeah. Well, it changes the width. Whether it makes it wider or tight, it actually makes it tighter. But it changes like the steepness, right? It doesn't move where it is. What's the -4 do?
The minus up.
Just move it down, right? So my parabola has been tightened and shifted down. My zeros will mirror each other, right? My parabola is still sitting right on the y-axis.
This?
Yeah, so nothing has flipped. So right now this parabola would be tighter. Crap. And that's not going to let me shift it. The very minimum would be on the y-axis. I'm just bad at drawing this. Down by 4. So that would be -4. And then out here, sorry, your 0, my stuff is off a little bit, would be 2/3 and -2/3.
Wait, so what does the x do? Regular x, no square.
Oh, the middle, the b
The
value.
b value.
we talked about this a couple weeks ago too. It shifts it in a parabolic fashion.
Oh yeah, where.
So I think we're gonna need to play marble slides again at some point.
No, I get it.
But the B shifts it parabolic. Like it does move it left and right and up and down. So it's really wonky. Trying to talk about what the B does is hard. This is easy and that's easy. Trying to talk about the B is difficult. Now my C value is 0.
Also, for any unknown value you don't have in the equation, just set it as 0.
I mean, I don't need to put plus 0. I could write it without it, but this clarifies.
Explains why.
That explains why
So-
I'm not using this equation.
Well, it would just be 0 and negative 16. Okay, X. I'm sorry.
So 0 and negative 16x.
0
you're
and
saying,
negative
like-
16 X add up to 16, and 0 times negative 16 equals 0.
Sorry, I hate this writing in blue. So you're saying 0x for one of the ones over here, and negative 16x one of the ones over here, but then how do I get my dimensions to do what I want?
Wait.
So I'm guessing this is going to be 0.
X doesn't make sense.
You just cut off the 0 part.
What do you mean?
Like, forget about the part that has 0, because it's no area.
Okay, well what's my factor form then?
Wouldn't that
It would just be 16x and x squared. There'd be no, like, yeah,
that'd be negative 4x.
yeah, it'll be negative 4x.
That'd be 4x.
Where? Here, this?
Oh, it would just be one number. It would be like one number and then a
That'd be 3x.
yeah, 4x and 3x. And then you have 1 on the bottom instead of. I don't know.
Close.
What?
Wouldn't it be 4x and then 3x?
Thomas?
That would be
What?
negative 4. That would be negative 4.
Didn't do it. I didn't factor out like that. Wait, how did I?
Oh,
Oh!
That would be negative 4.
It's not negative 4x, it's just negative
Negative
4.
4.
yeah.
So it just be
So-
4.
You guys are going to have a facepalm moment here.
Which one?
And that would just be
Yeah.
4x.
It doesn't have to be binomial. All because we end up cubic.
Yeah, we've had problems like this where there's only 1 here and then we have to.
So think about this. Distributive property, 4x times 3x. I got 12x squared. 4x times a negative, negative 16x. There's no other values to worry about. That's it.
I think I might have done something.
So what this makes are zeros. Again, we don't have to know this yet, but again, I'm pushing you to know those skills. If I set this equal to 0, one of these has to be 0. To make this 0, x could just be 0. That's one of my zeros. But to make this 0, opposite of your constant divided by your coefficient. Right? So the other one is positive 4/3. Those are my two zeros here. And if I put it in Desmos and graph it, that would work out. That would be where we cross it. So one of my intercepts on the x-axis is 0. My other one is at 4/3. So my parabola is going to look like something like that, where this crosses at 0 and that crosses at 4/3. So it just has been shifted a tiny bit. Because that b value, right? That b value shifts it both directions. So it went right and it went down. Good on this?
Yes.
C, we have all our values, but they were given in the wrong order. So when we fix the order,
We had a problem like that in the last one.
so I have 24k, and then, sorry, I guess down here goes negative 10k. Crap.
What? It's not
No, but I have a positive here and a negative there.
2 negatives.
Ah, 2 negatives. So what are we going to use?
Negative
Factors
6,
of 24.
negative 4.
Ah, negative 6 and negative 4.
I feel smart.
We can. It doesn't really matter where we put them. Sometimes it's easier to visualize. How do I get 4k from? Okay, so 4 would probably need to go here, which means that this would be 2k. Right, if that's 2k, well, to make my negative 4, so negative 1, and then to make this,
Is this a scam website? Like how to instantly get 4K?
no.
How to instantly get 4K vision.
So, and that's fine because there are multiple ways to do these. Do you have your 4K and your -3 down here?
No,
These are swapped.
I have it like
well, I have it so that it's -2K plus 1 multiplied by -4K plus 3.
Ooh.
You can't have pluses. You can't have positives there because you have to make a -10 here.
Yeah.
Actually,
Oh, wait, you put these negatives?
Yes.
Oh, you multiplied everything by -1.
Yeah.
You have the exact same thing. You just multiplied everything by -1. Yeah, you're fine.
Why doesn't this work?
So factor it out. Because Thomas, you actually tried like a little bit too hard. You didn't need to do that. But so your zeros. Hey, give me your attention for a minute. Thomas said he had -2K plus 1, -4K plus 3. That's the same thing because your zeros, opposite divided by coefficient, this 0 is 1/2. Opposite divided by coefficient, this 0 is 3/4. We'd get the same thing if we did the zeros of your factored form. So it's the same thing. It was
Really
just
tech
multiplied by
problem.
-1. And our last one here. This one's tough.
This one's fun.
Terrible.
I just figured it out.
Yeah, I know. I didn't.
Because I couldn't figure I thought that there was a 40 on top.
No.
It wasn't until B that I figured out that when you multiply them, then
Yeah.
the
At
0
least here.
cancels it out.
So 0 and squared here.
0. Then the left one.
My bottom's a -100m.
It's basically the same thing that you did in B.
0 multiplied by -100 then.
Yeah. It's
How's
the
that
same-
get me my 40 though?
Wait, there's a 40? What?
I got the 40. Which
Use
is
it
0,
zero.
Oh.
0, -100n. 0, yeah.
-0 and then -100.
And then I put
No,
a
B.
0 on the bottom left, a 20 on the bottom right, and a 2
Yeah.
on the top left, and
The 2 there and -5 there.
I know
on
I
the
did
side.
4.
Oh, you just flipped it.
What?
No, no.
A -5 on the bottom of the left side.
Here?
Yes,
Negative
-5
five
there,
M.
and then
Negative
a
five M.
2 on
Yeah.
the top.
Could you just get rid of that left side though again, please?
Except I had 4, -10 and 10.
So check it. 20 and 2, 40 works. 20 and 5m, -100 or -5. So that works. 0 and so my factored form. Or crap. Sorry. -5m plus 2
Yes.
Whenever you have 2 0 values in one
times just 20.
Did you get rid of the prime?
Couldn't it just recognize that up here I could factor out a 20 from the whole thing?
Oops. We should have.
And wouldn't that then just be 20 factored out from
Can I factor out 2?
-5? And you could, but then you can keep going.
That was
Factor
so much
about
easier
one.
than doing this
Because,
one step.
guys, what we're being asked to do, factor this expression. I don't need any of this nonsense to factor a common factor out of those.
So find a grade, just common factor and just divide it.
We've
And then
been
just
high.
rewrite it factored out.
Ooh.
So our zeros here, there is no 0 for this one. There is a 0 for this one. So -2 divided by -5, negative divided by negative. My 0 is 2/5. And what that means is that's the only point where I touch the x-axis. Because there's no 0 here. There's no way to turn 20 into
So
0.
mirrored.
So if I plug this in, it means it's been shifted like left or right. So Desmos,
So it never
let's
touches
get rid
what
of the
value?
x squared.
Would it never touch what?
So 0,
Oh.
I wanted you to figure this out before I got there. It only
no, I
touches
understand.
once, right?
Yeah, that makes
We
sense,
didn't
but
say it's still parabolic.
it's not parabolic.
It's not.
It's a line.
Because it touches once. It's a line.
Zoom out.
It doesn't look like it touches once actually.
The problem is the slope is so dramatic.
It touches multiple times.
It touches
Zoom in.
once.
Like, zoom
Well,
out.
So
very
2/5, right? 2/5, 0.4. There we go.
How far can Desmos
But guys,
go?
we should be able to see from this, it's not parabolic. Now, if it was still parabolic but only had 1, 0, then it means it just touches the axis and immediately goes back. It does not go through, it just touches it. Okay, let me check what we haven't gotten to and make sure there isn't anything very important. Yeah, then we get into some harder expressions using the area model. We'll pick this up tomorrow. Do your homework and bring questions. Depending on your questions will depend on what we do tomorrow. Okay, guys? Thank you very much. Have a wonderful rest of your Monday. Oh my God, Nidden! You set a booby trap. You got up and you immediately started lifting. You're about to crush Levi.
That was